Hi everyone. I've been teaching for more than 20 years. I've taught high school students, college students, and university students. And throughout this journey, I've had a good idea of the most common mistakes which students usually make in college algebra. Even some first year undergrads do some of these mistakes. Thus, I decided to gather all these mistakes in one video so that the students will have the chance not to fall into these traps. And I think that this would be beneficial for both students and teachers as well, because they will have all these common mistakes in one place and they can share them with their students. So let us start. The first mistake is in rational expressions. Many students cancel these x's, and that is wrong. I cannot cancel the x's if you have a plus in the middle. What do I do instead? Nothing, I just keep it as 2 plus x and 3 plus x. So we never cancel the x's if we have a plus or a minus in a fraction. We only cancel if we have a product. For example, if you have x into x plus 3, let's say, over x into 2x plus 5, since we have a product, now I can cancel. However, in the plus or minus case, we cannot. The second mistake is also in rational expressions, when we have a minus in the middle. So first, as usual, we have to find a common denominator. So we multiply this fraction by x plus 3 up and down. So this becomes x plus 1 into x plus 3 in the bottom, 3x minus 2 times x plus 3. And here's the mistake. Many students forget to add parentheses here. I mean these parentheses. And of course, if you forget to put parentheses, we won't be able to distribute the minus, which ends up being wrong. The third mistake is with square roots. If we have something like the square root of 16, some students simplify it as plus or minus 4, and of course this is not right. Why? Because the square root of 16 has a plus sign next to it. So I cannot say that plus is equal to minus. The good answer, however, is the square root of 16 is plus 4 only. Another mistake with radicals is when we have an even index. Let us start with an example in the square roots. If we have the square root of minus 6 all to the power of 2, the answer is 6. However, some students put minus 6, and again, this is wrong. Why? Because, as I explained in the previous video, the square root of x to the power of 2 is equal to the absolute value of x, which means the square root of minus 6 all to the power of 2 is equal to the absolute value of negative 6, which is equal to 6. In general, the nth root of a to the power of n, where n is even, is always equal to the absolute value of a. One more common mistake in radicals is when we multiply by the conjugate of a cubic root. Let me show you an example. Let us say we are asked to rationalize the denominator of this fraction. Many students think that the conjugate here is the cubic root of x plus 1. This is not right. Because again, when do we say that two factors are conjugates? We say that they are conjugates if their product ends up with no radical. And this is not the case here. This is the case if we have a square root. However, if we have a cubic root, we have to use the following identities. A plus b into a squared minus ab plus b squared is equal to a cubed plus b cubed, and a minus b into a squared plus ab plus b squared is equal to a cubed minus b cubed. So these are the conjugate terms in this case, which means the right way of doing this is the following. We think of this as the a and of this as the b, which means we multiply by a squared plus a times b plus b squared up and down. The next mistake is when we have a minus sign next to a fraction. So if we have minus a over b, this is equal to minus a over b as well as a over minus b. So all of these are the same. Now the common mistake is the following. Some students write it as negative a over negative b, and of course this is wrong because I will end up canceling the minuses, and this appears like a negative value is equal to a positive value. Mistake number 7 is about separating a fraction. In general, if I have a plus b over c, I can write it as a over c plus b over c. However, if I have a over b plus c, I cannot separate it as a over b plus a over c. So I can only separate it if we have the plus in the numerator, not in the denominator. One more common mistake in fractions is when we have complex fractions. Some students mix up between these two forms and they are different. In the first case, it'll be regarded as c over 1, and this becomes a over b multiplied by 1 over c, and this is a over bc. However, in the second case, I must put a over 1, and this becomes a over 1 times the reciprocal of b over c, which is c over b, and the answer is ac over b, and these are different. So this is why we must keep track of the bigger dash in the fraction. Let's move on to identities. This is not good. Why? Because we only have a difference of two squares and not a sum of two squares. The other mistake about identities is the following. I cannot distribute the n here. So a plus or minus b to the power of n is not equal to a to the power of n plus or minus b to the power of n. There are special identities that I have to use in order to expand this expression. We can use either Pascal's triangle or the binomial formula. So we can only distribute the exponent if we have a product in the middle or if it is a quotient, provided b is not equal to 0. Let's move on to the slope of a straight line. If I have a straight line in the general form, the slope is not equal to a. In order to find the slope, first of all, I have to write the straight line in the standard form or the reduced form, which is y equals to mx plus b, where m is the slope. Thus, I have to divide the entire equation by b, of course provided b is not equal to 0, so it becomes a over b times x plus y plus c over b is equal to 0. Then I isolate the y, and the slope is negative a over b. The next mistake is when we have a quadratic function in the vertex form. So if we have f of x equals to a multiplied by x minus h squared plus k, the vertex is hk and it's not negative hk. So for example, if we have f of x, let's say equals to 3 into x minus 2 to the power of 2 plus 5, then h is 2 and not negative 2. So h is always the opposite of what we have here. However, k is the same, so it is 5, which means the vertex is not negative 2, 5, it is 2, 5. What about the mistake in logarithmic properties? We know that ln of a or ln of a minus the ln of b, so we can pronounce it either as ln or ln, that is equal to the ln of a over b and not the ln of a over the ln of b. The next mistake is in equations. So if we have a times b is equal to 0, if I multiply two factors and the answer is 0, then of course either a is equal to 0 or b is equal to 0. However, if a times b is equal to some k which is not equal to 0, I cannot say that either a is equal to k or b is equal to k. That is wrong. For example, if we have x plus 2 multiplied by x plus 3 is equal to 0, then we say x plus 2 is equal to 0 or x plus 3 is equal to 0. However, if I have x plus 2 multiplied by x plus 3 is equal to 1, it is not necessary that either x plus 2 is equal to 1 or x plus 3 is equal to 1. That is wrong. So that's a very common mistake. The final mistake is also an equation, and it's a very, very common mistake. For example, if you have x squared is equal to x, never cancel x on both sides. That's wrong. What do I do instead? Well, I have to move the x to the other side. I have to make one side equal to 0. I factor, and then I say x is equal to 0 or x is equal to 1. If I cancel x from both sides, this means I have canceled a 0, and that's not good. And there is a common story here where if you have x squared minus x squared, for example, equals to x squared minus x squared, I will do it in the wrong way and show you what happens if you cancel a factor with x, or in other words, if you cancel 0. So I'm going to factor x here, and on the other side I will do a difference of two squares. Now x minus x is 0. That's the mistake that I did. I cannot cancel x minus x. But let us see what happens if we do that. So I'm left with x here, and I'm left with x plus x. That is 2x. Let us do the mistake again. So let's cancel x on both sides. And look what happens. We ended up with 1 is equal to 2. And of course, that's not good at all. So these are the most common 15 mistakes students make in college algebra. I hope you will find this video helpful.